Hey, welcome back to Tek-View. This is the second episode on our lessons on control structures. In the first episode, we looked at an introduction to control structures, the importance and uses of control structures, and of course the types of control structures we have in C++. We also discussed the sequence control structure. If you haven't watched our video already, please check that video out. You can check the video description for the link, or you can click on the link right on the screen to watch that video first. Today, we want to look at another interesting control structure called selection. I'm EJ Arthur. Let's get started. Selection control structures, also known as branching statement or conditional logic, are the structures that allow you to choose different paths in your program. In other words, these structures allow you to select some instructions to execute and some not to execute based on a defined condition or a condition that you set. Because of this, selection control structures are also commonly referred to as decision-making structures. They allow you to take decisions in your program. In C++, the three main decision structures that we have are the if-else statement, the switch statement, and the ternary operator. In this video, we are going to concentrate on the if-else statement. In subsequent videos, we will discuss the switch as well as the ternary operator. So stick around, and thank you for subscribing to the channel. But if you haven't already, kindly subscribe to the channel. Click on the notification icon to be notified each time I release new videos. Also like this video and share. If you have questions, do not hesitate to leave them in the comment section. Let's carry on. Let's begin with the if statement. The if statement enables you to test for a condition in your program and then branch to different parts of your code depending on the result of the evaluation of the said condition. So if you have an if statement, the if statement has a condition attached to it. So there's a condition that needs to be evaluated. If that condition evaluates to true, then a block of code that you attach to the if statement will be executed. If the condition evaluates to false, then that code or that block of code is ignored. So for example, if you want to check whether two variables are equal in your program and then branch to different parts of your code depending on the result, then of course you're going to use an if statement for that. In terms of syntax, this is how the syntax looks like. So this is the most simplest form of an if statement. So you begin with a keyword if. You remember keywords? Yeah, so you begin with a keyword if, and then you provide a condition in parentheses. So this is the condition that will be evaluated. Because this condition has to evaluate either true or false, it means that whatever condition you put there should be an expression that is going to evaluate to a Boolean value. So if that condition is true, then the block of code that you have in the curly braces are going to be executed. If the condition evaluates to false, or if the condition is not true, then that code, that block of code in curly braces are going to be ignored, right? So let's look at an actual demonstration. Over here, this is a code that checks if a number is even and displays the number is even if the condition is true. So in this code, we have an initialization statement here where you have an integer variable x initialized with the value 18. Right after this instruction, we have a conditional logic here. So as soon as you see the if, you know this is a conditional logic. So we are testing for a condition. Now we are saying that if the value that has been stored in x modulo 2 is equal to 0, then we want to perform this block of code that we have here. And in the block of code, we have just one statement here that says see out the number is even. So what is happening is that we want to, whatever number we have stored inside x, we want to divide the number by 2. If the remainder of the division is equal to 0, then we want to say that the number is even. We want to display the number is even on the screen. So just by looking at this code, we can analyze and see what's happening here, right? We have initialized x with a value 18, right? Yeah. So 18 divided by 2 gives no remainder. The remainder is 0. So in this case, this condition is going to evaluate to true because 0 and 0 are the same. So if that's the case, then it means that the number is even, is going to be displayed on the screen. But in a situation where x is not 18, right? If it's a different value. So for example, let's modify this code, and instead of 18, let's make x 19. So if we make x 19, then what is going to happen is that now when we check the condition, 19 divided by 2 gives a remainder of 1, right? And 1 is not equal to 0. So this condition has failed. Because this condition has failed, the rule says that the block of code can only be executed if the condition passes. Since the condition has failed, it means that we cannot execute this block of code. So we just have to move on in a sequential order. Remember that the default execution structure of any program is the sequential. So the program will run in a sequential form until it meets any other control structure or control logic. So when it started, it was running in a sequential order until it got to the if statement. When it got to the if statement, this condition failed. So there was a branching. So we branched from this instruction, and then we have to move to the next instruction. The next instruction in this code is the return 0. And because return 0 is just going to terminate the program because it is in the int main function, the program is just going to terminate with nothing on the screen. So let's run that to confirm that. And as you can see, when we make x 19, this time around, there is nothing on the screen because this condition failed. So this instruction was also skipped. Now the question you might ask yourself is, okay, so what if I want something else to be displayed if this condition fails? So for example, we know that if we divide a number by 2 and the remainder is not 0, then it means that the number is not even, the number is odd. In that case, if the condition fails, then we want to say that we want to have an alternative statement or set of instruction that we want to perform. In that case, we introduce what we call the else statement. The else statement. So the else statement is actually a clause, and it is a clause because you cannot use the else statement in isolation. You can only use an else statement if you have an existing if statement, all right? So if you have an if statement, you check a condition and you are interested in an alternative path or approach. If the first condition fails, then we introduce the else statement. So the else statement is used after an if statement when there is a need for another branch if the test condition evaluates to false. So together, if you put the if and the else together, we get what we call the if-else statement. So that's where the if-else statement comes from. The if-else statement extends the if statement and provides an alternative block of code to execute if the condition is false. So over here, we just have one condition to check. We have just one condition to check. But after checking that condition, if that condition fails, anything else apart from this condition, the else clause is going to handle that. Right, so that's what we mean by the else clause. So so let's look at the syntax of the else clause. So you have your if statement. This should always be there. You cannot have an else without the if. So the main condition is there. The condition you are checking is here. Now, if this condition fails, what is your backup plan, right? Yeah, so if your main condition fails, then what do you want to do? Then this one becomes your backup plan. So anything else is picked up by the else clause. So if this condition passes, we are going to execute this code. Now, mind you, if this condition passes, this one will automatically be ignored. It will not be checked. So the else is depending on the failure of the if condition. If this passes, if the main condition passes, the else clause will be ignored. But if this one fails, then now all the instructions that have been allocated for the else clause, they will be executed. Yeah, so this is an updated version of the initial code. Can you tell what this code does? You can put it in the comment section. Right, so we still have our condition here. Our x is initialized with 18. We still have our condition x modulo 2 equals 0, checking if the remainder is equal to 0. The action that is supposed to perform if this condition is still the same. But this time around, we are saying that if this condition fails, then we want to perform this action here. So by analyzing, you see that if this is 18, then this side is going to be 0. So 0 and 0 are the same. So you're going to have the number is even on the screen. But on the flip side, where we made x to be 19, for example, if we go back to that and make x 19 again, then this time around, when we run the program, you're going to see that we are not going to get this one. Instead, we get the number is odd on our screen. And that's because this condition has failed, so the instruction has fallen on the else clause to handle that for us. Now, there are situations where you want to or you need to test multiple conditions in a sequence. In a situation like that, we have what we call the else if statement. The else if statement. So the else if statement allows you to specify multiple conditions to be evaluated in a sequence. Remember, in a sequence, right? So in a sequential order. So the sequence control logic has also appeared here as well. It is used when you have more than 2 possible outcomes for a decision. So when you have just one main condition to check and you are interested in having an alternative branch if the main condition fails, then you use just the if-else statement. If you have just one condition to check and you are not interested in any alternate path, then you just use an if statement. If an if statement is standing alone without an else clause attached to it, we call it a freestanding if statement, or a standalone if statement, or an independent if statement, right? Yes, so we use that one when you have just one condition to check and you are not interested in alternative path. If you have just one condition to check and you are interested in an alternative path, then you use the if else statement. So the if statement for the main condition and then the else for everything else, like the backup plan. But if you have more than 2 possible outcomes, right? More than 2 possible. So in this case, we are looking at you have more than 2 specific conditions that you want to check. Then we use the else if statement. You still have your if statement. And then remember we said you have more than 2, right? So this is your first condition. This is the first possible outcome, the first condition you want to check. So condition 1. So if condition 1 fails, if condition 1 is true, these actions will be performed. But if condition 1 fails, then you want to check another condition, right? That's why we said you're checking multiple conditions in sequence. So if one fails, you want to check another one. If that other one fails, you want to check another one in that order. So if condition 1 fails, you want to check condition 2. To do that, the syntax is to write a keyword else if. So else if. So else if condition 1 has failed, then we want to check condition 2. That's how you read it, right? And you can keep on nesting these ones until you have exhausted all the specific conditions that you want to check. So for example, if I have about 5 specific conditions I want to check, I'll say if condition 1, then perform the actions that are supposed to be performed if that condition is true. Else if condition 2, then the actions that are supposed to be performed if condition. Else if condition 3 in that case. Then you can include the else clause, and you know what the else clause does. The else clause is in charge, is the default for handling everything else if all of the conditions fail. So if all of the conditions fail, then you use the else clause. So the else clause is going to handle everything else. It's like the master guy. If everything fails, then you fall on the else clause to handle that one for you. To better solidify all the concepts that we've learned so far with regards to the if-else statement, Let's write a simple program to mimic the behavior of a traffic light. Just as you already know, red means to stop, yellow means to get ready to stop, and green means you are able to go or you should go. Yeah, so to be able to do this, we are going to have a strange variable that is going to store the names of colors. So we can either store red, yellow, and then green, just to have that replicate the colors of the traffic light. In our case, we just need one variable because at any particular point in time, the traffic light has only one of its lights on, right? Cool. Let's start by saying that, okay, for now, we are only interested in knowing whether the red light is on or not. So if the red light is on, we are just going to stop, right? But if the red light is not on, then we are not going to do anything. So there's nothing's going to happen, right? So in that case, we are going to have if light equals red, then let's just see out stop, right? So if the light is red, we're going to display a message saying stop. But other than that, according to the description, other than that, there's nothing else to do. So other than that, we just leave it like that. So when we set the color of the light to red, and then we run the program, you can see that it now displays stop on the screen. But when we change the color, when we change it and make it, let's make it yellow. We'll make it yellow and we run, nothing happens. The same thing happens with green. When we make it green, nothing happens. All right. How about now we want to say, okay, if the red light is on, we want to stop. Other than that, we want to go. All right? Yes. So this is where we introduce the else clause, remember? So we just have to add the else clause. We say else. Now we see out go. That's what we want to do. So let's test the program again, first with red. And it tells us stop. Now let's test with yellow. Or maybe this time, let's test with green this time around. And it tells us to go. Let's try with yellow. And again, it tells us to go. Okay. How about this time around? We want to check if the red light is red, we want to say stop. If it is yellow, we want to say get ready to stop. And if it is green, we want to say go. So since we have more than two conditions that we are checking this time around, we are checking whether the light is red, or if it's not red, we want to check if it is yellow, or we want to check if it is green. So we have multiple conditions that we want to check. Because of this, we have to be using the else if clause. So now we modify and we say, in addition to the if statement, we introduce the else. So for now, let's get rid of the else clause. The next condition we are going to have, our second condition will be else if light is yellow. So we say if light is yellow, the action we want to perform is to see out, get ready to stop. And then the other condition is to check if the light is green. So another else if. So else if light is green. Don't forget to put these guys in quotation marks because they are strings. So if light is green, then we want to see out, go. Okay. So these are the conditions that the description wants us to work on. So you can see we don't have an else clause now, right? Cool. So let's run this program again and test with the individual colors and see. So let's start with red. Let's set our lights to red. Now you see it is telling us to stop. Let's check yellow. Yellow is telling us to get ready. Let's try green. Now green says we can go. Okay, let's try blue. And now nothing happens, right? Can you think of why nothing is happening? If you are guessing it's because it is not part of the conditions, then perfect, you are right. Because the conditions that we said were specific conditions, red, yellow, and green. So if none of these ones are in there, then we are not getting any action performed. And also remember that we do not have an else clause. But we know the function of an else clause. The else clause is going to handle everything else if the specified or specific condition fails. So if specific conditions that we have set fail, then the else clause, if it exists in our program structure, is going to handle everything else. So let's add an else clause. So in our scenario, a practical use of the else clause would be, for example, if there is no light on, right? We can have a situation like that. Like if the traffic light is faulty, then there will be no light on. Or there are multiple lights on at the same time, stuff like that. Then in this case, the else clause can handle all of these ones. So let's add the else clause. So else, don't forget that when you add the else, there is no specific condition you add because it captures everything else. So we say else, we are going to see out maybe traffic light faulty, or maybe the traffic light is faulty, something like that. Yeah, traffic light is faulty. So now let's still maintain the blue and now run the program and check it out. And now you can see that it is now telling us that the traffic light is faulty because I don't know if there's a traffic light somewhere that has blue lights, but here in our region, we do not. If you know a country where their traffic light has blue color in it, let me know in the comment section. Maybe I would like to visit that country one of these days. Fantastic. Yes. So I hope you have learned something. There are so many other ways of doing this traffic light project. As a challenge, I want you to try how you can do this. Instead of using a strange value, how you can use a Boolean value to be able to achieve the same goal of having traffic light, replicating the traffic light system. In our next video, we are going to look at how we can use the switch statement to take decisions or to make selections in our programs. So watch out for that video. Be sure to subscribe to the channel. Click the bell icon to be notified when new videos are released. Like and share. Let's get interactive in the comment section. Take good care of yourself out there. Let's view the world in a technological way. Peace out. I'll see you around.